Hello, ladies and gentlemen. My name is Mr. Bryce, and I'm with Susquehanna Valley High School here in Concord, New York. And today, we're going to be going over the Algebra 1 Common Core Regents from Wednesday, June 17th, 2015. So this is the 2015 June exam. And we're starting off with question number 25, which is the first two-pointer, where you have to show your work. Graph the function y equals the absolute value of x minus 3 on the set of axes below. Okay, well, you could pick my favorite numbers, or you could grab your graphing calculator and hit y equals the absolute value. Well, that's the math button. Right arrow to numbers, choice 1, absolute value. And it says type in the x minus 3. So a quick review. You hit the math button, right arrow, 1, which is absolute value. Then you type in the equation. Now, we're going to go right to the table. If you notice, this is an accident, but if you notice on the table, these two numbers match, those numbers match, those numbers match, and then there's one number in the center. That's exactly what we wanted to look for. So we're going to copy that down onto our paper to show our work, because that's the table. Now, if we didn't see that at first, you could see that, oh, there's an 8 and a 2. Those don't match. It's not symmetrical. The absolute value makes a V, just like a parabola makes a U, so we want to have that kind of pattern. So we scroll until we can see that V. Now here's something else. While this is here, we're just going to hit graph, and we can see that it bounces off 1, 2, 3. It bounces off the 3 for X, so that's why we want that to be in the center of our table. So we just graph it. I'm going to hit pause here. Now notice the question says graph, it doesn't say plot. Okay, and an absolute value, we do graph. It doesn't give us an interval. It doesn't say from x being 0 to 3, or from -2 to 5. And then we label it y equals the absolute value of x minus 3. Please, just put a little bit of a scale on there. Explain how the graph y equals the absolute value of x minus 3 is changed from the graph y equals absolute value of x. There it is. Why don't we take a look at y equals the absolute value of x? It moves 3 places to the right. Now, if we wanted a little bit further explanation, why did it shift 3 places to the right? Because inside the absolute value, there was the x minus 3, and the minus 3 made it go to the right. If it was plus 3, it would go to the left. Inside, we go the opposite direction, left to right. Outside, if it says minus 3, the vertex goes down 2. If it says plus 3, the vertex would go up 3 on the outside. But since it's on the inside, the vertex goes the opposite direction that it says. That's number 24. Sorry, 25. Let's look at number 26. On first blush of going through this question, you think it's going to be a tough question, but it isn't. Alex is selling tickets to a school play. An adult ticket costs $6.50. A student ticket costs $4. Alex sells, so he sold X adult tickets and 12 student tickets. Write a function to represent how much money Alex collected. Money. By the way, I'm going to write down f of x down here also. The money, let me see, $6.50 for each adult ticket. So doesn't it make sense that I do $6.50 times the x, times how many adult tickets there were? And then, let me see, 12 student tickets, and each student ticket costs $4. So the function f of x is 650x plus 48. That's how much money he collected. Make sure that it makes sense. $48. Oh, because it was $12 or $4 per 12 student tickets. Okay, that's $48. We know he has at least $48, but we can figure out how many adult tickets he sold just by knowing the total money he collected. This is the amount of money I collected. We can figure out that. Is there anything else on this paper? Nothing. Turn the page. Number 27. John and Sarah are each saving money for a car. The total amount of money John will save is given by the function f of x equals 60 plus 5x. The total amount of money Sarah will save is given by the function g of x equals x squared plus 46. After how many weeks will they have the same amount of money saved? Explain how you arrived at your answer. Two ways we can do this. See this? See this word? See that word? Same. Same means equals 60 plus 5x equals x squared plus 46. If they say solve this algebraically, this is how we have to do it. I'm going to move everything to the x squared side. Now move the 5x over. Please don't do x squared minus 5x equals negative 4x. Please don't do that. They're different animals. Okay. Now, you can factor it. What two numbers multiply to be negative 14 and add up to be 5x? You can also complete the square. Remember, completing the square will solve every factorable problem. Okay, so here, because there's no number in front of the x squared, okay, I can do this method. I can do the x box. There's no need for me to do the box part of it. But just in case you don't know, you're like, that's x squared. That's negative 14. Remember this? Then we have negative 7x, and we have positive 2x. What's the greatest common factor between x squared and 2x? That's just x. And the greatest common factor between those two is negative 7. And then you think, x times what is x squared? X. Now negative 7 times x is negative 7x. It checks. And then x times what is 2x? That would be 2. And negative 7 times 2. So there are the factors. X plus 2 and x minus 7 equals 0. The multiplicative property of 0 means that we can set each of these equal to 0. And so x equals negative 2 and x equals positive 7. Let's see, are there going to be any problems with either of those answers? Sarah, they're each saving money. Well, can we have something be negative 7 or negative 2 weeks ago? Negative 2 weeks ago, they had the same amount of money? No. No. So how many weeks? Only positive. So it's 7 weeks. Okay, I said there were two ways. You could graph these and see where the tables are exactly the same. Okay, you can have x and then y1 and y2. And you would see that at 7, whatever this number is and whatever that number is exactly the same number. Copy down both tables onto the piece of paper. You got it. Number 28. That was the bell for class to begin, so I'll do number 28.